Good day, everybody. Welcome to 8th grade algebra. This lesson is what we're calling week 28, mixed practice, day 1, sketching piecewise functions. On a side note, hope you're all doing well, if you're taking care of yourselves and those you care about. I'm going to start with a quick story here. So I'm wondering if any of you have ever met somebody like Regina George from Mean Girls, where they act one way when they're around some people and another totally different way when they're around other people. Like maybe they're super nice and sweet when they're around their family, and then the minute their mom turns their back, they're terrible. Today we're going to talk about a type of function that behaves the same way, where sometimes it looks one way and sometimes it looks completely different. These functions are called piecewise functions, but before we get into those, let's remind ourselves, most functions we're used to seeing behave in a predictable way. You can see this line that goes up from left to right, this line that goes down from left to right. You see this line that goes straight horizontal from left to right. Even something that's not linear, like this quadratic function, it doesn't consistently go up or down, but it follows a predictable pattern no matter where you are. It follows the same function, regardless of what the x value is. These piecewise functions do not follow that same rule. In fact, they follow one set of rules if x is less than 2, and another set of rules if x is greater than or equal to 2. Some functions are defined for different x's in particular. Some are defined over a certain range of x's or a domain of x's. So here we'll see this f of x. We're going to see how this behaves and what it looks like on a graph. When x is less than 2, it's going to look like this red line. This is the line of negative x plus 2. When x is greater than or equal to 2, it's going to behave like this blue line, which is 2x minus 3. You put those together and on the graph, it looks kind of funny. It looks like this. You'll see that it follows the rule y is negative x plus 2 if x is less than 2. And then the minute x is 2, it's totally different. It follows this rule, which is y equals 2x minus 3. Now, you might wonder, what would happen right here at x equals 2? Well, to figure that out, we look over here on the left and we say, well, if x is less than 2, it follows this, but that's not including 2. That would have been an open dot. 2x minus 3 if x is greater than or equal to 2. So that's what happens when x is 2. So when x is 2, the value of this function, it'll follow this second rule. And it'll be 2 times 2, 4 minus 3 is 1. So the value of f of 2 is 1. That's why you have a closed dot here. In terms of where we put these arrows, it's important to know this function goes on all the way to the left, all the way to negative infinity, and this function on the right goes all the way to positive infinity. So when you finish graphing it, it's going to look like this. A closed dot here for this part at x is 2, and here when x equals 2, it's a closed dot. Sorry, this first was an open dot. And then you'll have arrows going off to negative and positive infinity. Now we're going to check for some understanding. Take a look at this piecewise function. I want you to be prepared to one, graph, and then share what is the domain and range of the function. Go ahead and pause and graph this function on your own, and then be prepared to find the domain and range. All right, welcome back. Hopefully you've graphed this function and you have a sense of what the domain and range are going to be. Your graph should look something like this. Notice I've left off the arrows and dots in the very end because we have a couple questions for you. For finding the domain and range, we have 3 options. Option 1, option 2, option 3. Read these options to yourself and be prepared to share which one you believe is correct. That's right. It was this one. And the reason why the domain is all real numbers is because it is defined at x equals 4. In fact, it's this second function when x equals 4. So it is defined. It's true for any x. You could put it in and you could find the corresponding g of x. So the domain is all real numbers, including 4. The range, you might notice there's no values here below -1. So that was common for options 1, 2, and 3. So we know it's -1 and more, but we're not sure if it includes -1 or not. And to do that, we need to actually go back to the function. We figure out, is there a closed or open dot there? What we find is this line here actually ends and doesn't include this point, which means that we don't have the point y equals -1 or g of x equals -1 anywhere, which means the range is all real numbers greater than -1, not including -1. We don't include that one. All right. With that, I just wanted to stamp some big ideas for you. One, these functions follow different rules over different parts of their domains. Two, I want you to be careful when graphing to ensure that you're attentive to arrows when a pattern continues everywhere in that direction, open circles when a graph does not include the endpoints of a segment, and closed circles when a function does include the endpoints of a segment. Now you're going to go on to practice. Your teacher is going to share some guidance around how to record your answers and how to share it. Looking forward to seeing lots of learning coming from this. Good luck, everybody.